Hello everyone and welcome back to Level Up STEM for another calculus practice problem. Today we will be going over two problems about limits and continuity. And make sure to like and subscribe if you haven't already. Thanks. So a portion of the graph of a function f is shown below. Note that f of x has a vertical asymptote at x equals 2. Okay? For which of the following values of a is f of x continuous at x equals a? And then they give us 4 options or none of them. Okay, to begin this problem, I want to recall the conditions for continuity about some point A. So the first condition is that f of A has to be defined. There has to be a y value for this given x value. That's just pretty obvious. And the second condition is that the limit as x approaches A of f of x exists. I think this one's pretty much telling you that as you come from the negative direction and the positive direction, that same limit has to be equal between both of those. And the third condition is that the limit of x as x approaches a of f of x has to equal f of a. What this basically prevents is any holes. So any holes would not justify a continuous function. So let's begin by looking at each of these a values. We have a equals -3 to begin. And as you can see from the negative, it's approaching, looks like y equals 0. And also from the positive, it's approaching y equals 0. So I think that would exist. There's no holes or no asymptotes or anything. So that one should be one of them. Now let's look at -2. So as we come from the negative, it looks like it's approaching y equals 1. As we come from the positive side, it's also approaching y equals 1. But as for this third point, the limit of f of x as x approaches a, that equals 1. But the actual f of a value is 2. So those don't agree. So that third postulate is violated. So because of that, a equals -2 is not an answer. Now let's go to 1. A equals 1. And you can see at this, it looks like there's no holes, no asymptotes or anything. It's one flowing function. And we can see from the negative, it approaches, looks like y equals -2. And also from the positive, y equals -2. And it's defined at y equals -2. So that would be an answer. As for a equals 3, we can see that as we come from the negative side, it looks like it's approaching 0, and there's a hole, and it jumps to 3. So if you go from the positive side, we have a y value of 3. So those two sides of the limit, they differ, right? So because of that, it doesn't exist. The overall function doesn't exist. So that would not be an answer. And clearly, neither would none of them since we have 2 correct answers. Okay, moving on. We have the same setup here, and for which of the following values of b is the limit as x approaches b from the positive side of f of x equal to f of b? Okay, so let's begin by looking at b equals -4. So we're only referring to the positive side here. So as we come from the positive side, it looks like the limit equals about 1. The y value is about 1. And we don't really care about the negative side other than, yeah, actually we just don't care about it. F of b is also 1, so I think because of that, those two things should equal at b equals -4, and that's one of your answers. For b equals -2, as we come from the positive side, right, that's 1 again. But f of b is 2, so those two things are not equal at that point. So that at b equals -2 would be not an answer. And as we go to 0, b equals 0, we can see that as we come from the positive side, it looks like we're approaching 1, and that actually is the f of b value is 1 at that point, so that is an answer. As for b equals 3, as we come from the positive side, that looks like it's approaching -3 down here, and that actually, because it's filled in on that dot right there, that's the actual value of the function. So the actual value of that function is defined at -3. So because of that, those are actually equal. And once again, none is not an option. Okay, so we're moving into taking limits of specific callouts here. So the limit as x approaches -2, and we're gonna, or 2 from the negative side, excuse me. Or no, I'm sorry, that is x approaches -2. So let's look at that. So the limit as x approaches -2 from the negative, looks like it's 1 again, and as it approaches from the positive side, it's 1 again. So just by reading the graph, we can determine that that limit is 1. Okay, let's move on to another one here. So we have the limit as x approaches 5, okay? So we have from the negative side, it's approaching, it looks like that's y equals 1 at that point. And as it's approaching from the positive side, it's y equals -1, right? As follows. So those two things disagree with each other. And because they disagree with each other, that limit does not exist, or DNE, like they want you to write. For this question number E here, we have the limit as x approaches 2. And let's look at from the negative side, that's approaching infinity, and also from the positive side, that's approaching infinity. And now we have this weird E thrown in here. So just by reading the graph, we know that the normal f of x approaches infinity. So now we have to deal with this E, and we can just plug that in. We have infinity as the answer for the limit of f of x, so we can just plug in e to the negative infinity based off what we're given here. And that can be rewritten as 1 over e to the infinity, because that's you're allowed to do that when you have negative exponents. And by doing that, you have some really huge number, because infinity is just, think of it as the biggest number you can possibly think of, and it's just bigger than that though. So 1 over whatever this is, 1 cajillion, is going to basically equal 0. So in the math world, we basically allow that to equal 0, and that would be your limit. For part F here, we have the limit as h goes to 0 of this expression here. And now this expression here looks pretty familiar, and that's because it's the definition of derivative. F prime of x equals exactly what's right there. So because of that, we can essentially take the derivative at x, x equals -6, and that's just the slope of this line right here. So the slope of that line, it looks like we're gonna rise down by 1 and go over by 2. So that should be -1/2, and that is okay. Make sure to like and subscribe, and we'll see you in the next video. Peace.